Okay, so this video has 4 examples. Please pay attention to the timestamps on the video. On the progress bar, it'll be example 1, example 2, example 3, and example 4. Whichever example intrigues you the most, you can just go straight to that one. Without any further ado, let's get to the introduction. Okay, so now what I'm going to be doing, and this is without much theory on all of this, I'm basically just going to be going over how to deal with double and triple integrals. Now, I'm no Calculus 3 student, okay? But I have been learning this on the side. And I do want to show like how to go about doing double and triple integrals. So just bear with me right now. And then don't worry, I'm pretty sure later on next year I'll be able to do more advanced methods, and like I'll at least be able to understand this fully. But right now, I just feel like doing this video, so that maybe I can just revise back on my own videos, I don't know. Anyway, let's do the introduction to double and triple integrals. Well, what we're going to be looking at is, it's going to be multivariable functions, right? So let's look at our double integral. We know let's look at our single integral, right? So we know our single integral. Let's look at it as definite integral, bounded from a to b, of a function, right? A singular variable function with respect to x, right? This is our single variable function, integral. Okay, and now let's look at our double integral. What I'm going to do actually is I'm going to call this x1, I'm going to call this x2, right? Now our double integral will look like this. It'll be from x1 to x2, and then our second integral will look like this. It'll be from y1 to y2, and then it'll be a function of x and y with respect to x and y, like that. Okay, so that's something new, right? If you're here for the first time, you're not really used to the multivariable functions with the integration. You're just used to your standard single integration. Now let's look at the triple integration. The triple integrals, well, it's no surprise, it's going to be 3 integrals. It's going to be integral with x1, x2, then we're going to have the second integral, it's going to be y1 and y2, then the third integral, it's going to be z1 and z2, and this is when we're going to be introduced to the z-axis. Okay, and this is our third variable, so it's going to be the function of x, y, and z. Okay, with respect to x, y, and z, respectively. Okay, so this video will just be covering how to integrate with more than one integral. So one thing that we need to take into consideration, right? Oh, I mean, I don't really need to go through it now, because when we do the examples, you'll see it's basically just what we are. It's basically the whole video is going to be based on what I would have just done right now. I'm just introducing you to what it looks like, right? We'll have a function, but in terms of 2 different variables, right? Because normally we would do it in terms of 1 variable with respect to only 1 variable. This time we're doing it with respect to 2 variables, which is x and y. And then if it's triple integrals, it's with respect to 3 integrals. Okay, let's move on to the first example so we actually know how to do this integration. Okay. All right, so there's the first example. What we have is the double integral. We have 2 variables. We have x and y, and it is with respect to x and y. Okay. Now, what are we mainly looking at right now? Well, first of all, whenever we're doing double integration or triple integrations, we are actually going to start from the middle. We're going to integrate from the middle, meaning we're going to start from here with respect to whatever. Let's say this is y, and here's the part where we're going to have a problem. We need to manipulate this integral such that we are actually able to integrate. So basically, this is how we are going to go about doing it, right? So this is going to be equal to, and watch which one, how am I going to go about saying this? Oh yeah, sorry about that. What I always recommend is whichever integral you have, with your bound, whenever you have both being constants, you always put it at the beginning. Like this. It'll come right at the beginning, meaning you'll work with it last, so that your final answer is a number. And what you can see over here, we have a variable, x squared. And that is weird. We never actually worked with this before. Now let's just go into this. Let's just do this example, and you'll understand why how this is going to be done. We need to manipulate this, right? And it's better to work with the integral with the variable a part of the limits, the upper limit and lower limits, right? So therefore, what we're going to be doing, we're going to keep this integral 2 and x equals to 0 at the beginning, so that we can work with it last. And then we're going to actually move the x outside. We can actually treat x as that constant of where we have the integral in terms of y, or with respect to y. Okay, because we're not really going to be dealing with the x right now. We can actually just take it out, and then therefore we'll have x outside, and this will be multiplied by the integral, and then the x squared as the upper limit, and then y equals 0 as the lower limit. Okay, and then we'll have y left over here, but now we need to rearrange this dy and dx and dy. Well, first of all, because we're going to be working with the middle integral, it's best to actually put dy over here and dx over here. Meaning that if we were to isolate the middle integral, we would have this right here. Can you see that this is just our normal integral? So let me rewrite this one in red. And this is what I'm going to be doing throughout this whole video. Whatever I put in brackets in red, I'm going to be dealing with it separately and plugging it back into our main integral. So basically what we have the integral from y equals to 0 and y equals to x squared. Note how both of them are y. Of y with respect to y. Okay, and we can actually do this integral. Well, if we were to integrate this, we'd get the following. So we're going to have y to the power of 2 over 2, and then we're going to have it evaluate from y equals to 0 and x squared. Well, y is equal to x squared. Let me just keep it as y is equal to x squared. And why is this cool? Because we know that y is actually equal to x squared, meaning when we evaluate, we can just plug it into y. And we know our form of f of b minus f of a. We're going to write it in that form. Okay, so we're dealing with the upper limit, then the lower limit. So it's going to look like this. It's going to be, we're going to substitute x squared into y, all squared. And then it's basically just going to look like this, over 2. This is going to be minus, now we're going to plug in the lower limit, which is going to be 0 squared over 2. Okay, and we know that this is just going to give us the answer of 0, and therefore we are just left with x squared all squared divided by 2, which we can write as x to the power of 4 over 2. So this is what we can plug into the middle of the integral that we had over here. That is basically just evaluated from this. So we're just going to plug it in. I'm just going to cut to the part where I actually plug in all the stuff, okay? Now, what do we notice over here? Well, clearly this integral is the same in the black, right? The integral in the black is the same as what we have in black over here, right? Outside of the bracket, the red brackets. And whatever was in the red brackets, we evaluated to be x to the power of 4 divided by 2, which we just plugged in over here from that evaluated integral. And what can we do now? Well, we can clearly simplify, right? Well, we can write it like this. We're going to have integral from x equals to 0 to x equals to 2 of x multiplied by a half. We can write this as a half multiplied by x to the power of 4 with respect to x. And because we have a constant, we can take the constant out. Okay. Then therefore, this will be equal to a half integral of x equals to 0 until 2. And then we'll have x multiplied by x to the power of 4, which we know we can write it as x to the power of 5 due to our exponent laws with respect to x. And look at this. This is perfect. We can just straight up integrate it. So it'll be a half, and then we're evaluating this integral. The integral of x to the power of 5 is going to be x to the power of 6 divided by 6. And then this is evaluated from x equals to 0 and x equals to 2. And can you see we can just straight up get an answer, a value. This will be a half multiplied by, and we're just going to use that same format we just did with the other integral where we're evaluating. We're going to plug in our 2 first, which is our upper limit, and it'll be 2 to the power of 6 over 6 minus, it'll be 0 with our lower limit to the power of 2 divided by 6. And we straight up know that this is going to be equal to 0 because it's 0 divided by something. And then therefore it's going to be a half multiplied by, and 2 to the power of 6 is just going to be equal to 64. Sorry, I took a while over there. and then this is divided by 6. And then what we can do over here, we can see that we can cancel some of this over here. This will be left as 1, this will be 32. Okay, and then therefore what we are left with is 32 divided by 6, which we can actually just evaluate, or we can simplify further, and then we can write this as, I believe it would be 16 divided by 3. And that would be the answer for this integral over here, this double integral. Let's move on to the next one. Alrighty, so what do we have over here? Well, this one looks a little bit more weird, but hey, guess what? Doesn't it look a little bit better, the fact that we don't have any variable in our bounds of our limit, of our integrals, sorry, not limits, integrals. First of all, what we remember from muscle memory of singular integrals is that we can just take this out, right, out of the numerator. So let's just do that, right? So we're going to have the integral x equals to 1 to 4, and then the integral x of y equals to 4 to 9, and then we have of 1 divided by root xy with respect to x, with respect to x and y, respectively. Okay, isn't that looking a little bit better now? Well, it's still looking weird. Well, what we can actually do, right, and I'm going to write this in red, from here, we can actually write this like this, right? So 1 over root xy, this can also be written as 1 over root x multiplied by root y, which we can actually just break up into 1 divided by root x multiplied by 1 divided by root y. So I'm just going to write this over here. I'm going to write this into that. Okay, so therefore what we're going to have is the integral from x equals to 1 to 4, the integral of y is equal to 4 until 9, we're going to have 1 over root x multiplied by 1 over root y with respect to x and dy respectively. Okay. And now remember what we did earlier with whatever we had with the integral where x is the bound, right, where we're evaluating into x, we're just going to move all of the stuff that has x towards the x integral and all of the stuff that has y with the y integral, which we can keep the 1 over root y in the same spot. Okay, and we're obviously going to rearrange the dx according to what we have. So because we have constants in our integrals, we don't really need to rearrange the integrals. We can just straight up do whatever we want right now. So we're going to keep the x over here on this side. We're going to have x equals to 1 until 4, and then we're going to, remember we took the 1 over x, root x to this side. Then we're going to have the integral from y equals to 4 until 9 of 1 over root y. With respect to, we're going to put y here first because you're going to deal with this integral, and then dx is going to be here. Meaning that this over here is like this. Okay. So this is perfect. Now what do we have? If we isolate this middle integral over here, we can just straight up integrate. Isn't that correct? So let's just write it like this. Okay. So we're going to write the red over here. We have the integral of where y is equal to 4 until y is equal to 9 in the limits, and then we're gonna rewrite 1 over root y as y to the power of negative a half. You can also write it like that with respect to y, and now we can actually integrate from here. Okay, so this is going to be equal to, well, we're going to keep it in parentheses, and then we can write it as y to the power of negative a half plus 1, which is equal to a half, divided by a half. Okay, and this is evaluated from y equals to 4 and y is equal to 9. And then obviously that's just simplified over here. We can actually rewrite it like this. It's going to be, well, divided by a half means multiplied by 2, right? It's the reciprocal. So it's going to be 2 multiplied by y to the power of a half, which is also equal to root y. Okay, and then this is y equals to 9, y equals to 4. And look at this. We're going to use our definite integral method, where we're going to say the following. We're going to say 2 root, we're going to use the upper limit first, it's going to be 9, minus 2 root, the lower limit, which is 4. Okay, and then we're just going to evaluate more over here. We're going to have 2 multiplied by root 9. Root 9 is equal to 3, so this is 2 multiplied by 3 minus 2 multiplied by root 4, which is 2. And then therefore we're going to have 2 times 3, which is 6, minus 2 times 2, which is 4, which is equal to 2. Therefore the evaluated answer for the middle integral with respect to y is equal to 2. Meaning we're going to plug in 2 into this red bracket over here. Okay, so let me cut to the part where I actually do that. Okay, now look at that. We just replaced the 2 into that now. Okay, so now from here, well, clearly we can just take this 2 out, right, as a constant. Therefore, we're going to have this equal to 2 multiplied by the integral, where x equals to 1 until x equals to 4. And then we're going to have we can actually rewrite 1 over root x as x to the power of negative a half, okay, with respect to x. And there we go. Look at that perfection. We can integrate from here. So this will be 2 multiplied by the bracket where we're going to evaluate, we're going to have the integral of x to the power of negative a half. We can also write this as x to the power of a half divided by a half, and then evaluate it at x equals to 1 and x equals to 4. And then what else do we have? Well, we can simplify the following, right? We're going to have 2 multiplied by, well, we can actually write this as 2 root x, evaluated x equals to 1 and x equals to 4. Okay. Now we're just going to plug the stuff in. We're going to have 2 bracket, we're going to have 2 root, we're going to deal with the upper limit first. It's going to be 4, and this is going to be minus, and then we are going to have 2 root 1, which is the lower limit. And therefore, it's going to be 2 multiplied by root 4, that's just 2 multiplied by 2, minus 2 multiplied by root 1, which is 2 multiplied by 1. And then therefore, we can actually just simplify further. We can say 2 multiplied by, this is 2 times 2, which is 4, minus 2 times 1, which is equal to 2. And therefore, this is 2 times 2, which is equal to 4. And that's the answer of this integral. Okay. Let's move on to the next one. And the next one is going to be our triple integral. Whoa! So here's our triple integral. Now, there's nothing too crazy about this one. It's just that we have to do extra work. So instead of having 2 integrals, it's 3 integrals. Very straightforward. Damn, now you're going to pass with flying colors. The fact that I just told you that. Okay, but anyway, jokes aside, what are we going to do, right? Well, clearly we are already set up. This is perfect. We have our integral where we have the limits being constants at the beginning, which is exactly what we want to do at the end. But we have something weird. The order is messed up. And plus, we just have 3 variables in the middle, which is our function in terms of x, y, and z. Function of x, y, and z respectively. Okay. So now what we're going to do, we're just going to rearrange this integral. Well, we can actually rearrange it as the following, right? We can actually end it off, well, we're going to have the beginning with x equals, right? With x equals to 0 and 1. And then we're going to have x over here, because we're going to take the x all the way to the x integral. Okay. Like that. And now we're going to have the integral of, which one should we do? Well, clearly what we have over here, if we deal with our z integral, we can actually get our y evaluated, and then we can plug in that y into our y integral. So we should rather keep the y integral as the second one, meaning we're going to have y equals to 0 here until x squared. This is also y equals x squared. And then we're going to take the y to the y integral, so therefore it's multiplied by y. And then we're going to have the integral of z equals to 0 until y, and then we have of z. And then this is with respect to, remember the order is important. We first have z in the middle with respect to z. Then we have y over here, which is the second last one, which is dy. And then we have the beginning, which is going to be dx. And you can see it follows the order. We have with respect to z, then we have with respect to y, and then we have with respect to x. That is why the order is important, because we have to do our integration. We have to have our order correct in order for our solution to be correct. Otherwise, you're just throwing away marks. You're throwing away marks. Now, just like the double integrals, we're going to work from the center, the middle, meaning this integral here with respect to z. So that's what I'm going to do in red rather. So I'm going to put this equal signs here. And then therefore what we have is the integral from z equals to 0 to z equals to y of z with respect to z. We can straight up just integrate from here. We're going to put it in parentheses, and we're going to have the integral of z is just equal to z, and it's going to be 1 plus 1, which is 2, and then this is divided by 2. Okay, now I'm going to actually confuse them with z and 2, so let me just do it like this. Okay, and then we're going to have from z equals to 0, and then z equals to y, like this. Okay, we're going to evaluate from there, and then therefore what we're going to have is we are going to have, well, let me put this like this. It's going to be y squared. We're plugging in the y first, and then this is divided by 2. And this is going to be minus. Now we're going to plug in the 0. So it's 0 squared divided by 2. And then therefore this can evaluate further. We know that this will just give us 0, so we don't have to include it. This is going to be y squared divided by 2. And now we can just plug that into the integral that we had so far. Okay, let's just cut to that part. Now I think my biggest problem is the fact that I always confuse the 2 and the z. That's probably where my incorrect solutions come from. So if I do make that mistake, I do apologize. Or I'll probably just end the video and recreate a new one. So yeah, well, I'll just edit that part out. It's crazy. But anyway, yeah, we have this now, right? Which is our evaluated, which is evaluated from the integral over here with respect to z. So we're just going to continue, right? Now we're going to move on with this middle integral, which is with respect to y. And now we're just going to do the following, right? So now this is the new red that we're going to be working with. So this is actually going to be equal to, let's deal with the red bracket now over here. So the integral from x squared, from y equals to 0 to y equals to x squared of y multiplied by, we can rewrite this as 1 over 2 multiplied by y squared. And this is with respect to y. And now obviously let's just simplify this. We can take the constant out of the integral. Then we'll have 1 over 2 integral of, it's going to be from y equals to 0 to x squared. And then we are going to have of y multiplied by y squared just gives us y cubed with respect to y. And now we can just integrate from here. Okay. Therefore, we're going to have a half multiplied by the bracket. Integral of y cubed, we can write this as y to the power of 4 over 4. And then we'll have y equals to 0 and y equals to x squared. And then we can just evaluate from here, okay, in terms of x. So we have 1 over 2 multiplied by, and the first one's going to be the upper limit, which we're going to have x squared all to the power of 4. This is divided by 4 minus, and we're going to have 0 plugged in, all to the power of 4, sorry, divided by 4. Okay. And now we just simplify further. We know that this can become 0. We don't have to include that. Then therefore it's going to be a half multiplied by, or we can just say multiplied by x to the power of 2, and then all raised to the power of 4 like this. We know that these two are going to multiply each other due to exponent laws. Therefore it's going to be x to the power of 8 divided by 4. And then therefore this will simplify to x to the power of 8 divided by 4. Or no, 2 times 4, which is equal to 8, like that. And then guess what? We have our integral with respect to y now, which is that one there. So let's just rewrite it in terms of what we evaluated. Wow, that looks so simple right now. Look at that. Well, now what we have over here is just the integral with respect to x, right? That is perfect. Also, I apologize about the noise in the background. That's my phone. So let's just break this up. Now, we only have one integral, so we don't need to do color coding anymore. We have from x equals to 0 to 1 of x multiplied by, we can rewrite this as 1 over 8 multiplied by x to the power of 8 with respect to x. And therefore, what we can do, we can take the 1 over 8 outside as a constant. So it's 1 over 8 multiplied by the integral x equals to 0 and 1. We're going to have x multiplied by x to the power of 8, which is equal to x to the power of 9 with respect to x. And then therefore, we can actually just integrate from here. Okay. Then therefore, we're going to have 1 over 8 multiplied by this integral now. The integral of x to the power of 9 is x to the power of 10 divided by 10. Evaluated at x equals to 0 and x equals to 1. Okay. Then we're just going to plug in our values. Therefore, we're going to have 1 over 8 multiplied by, we're going to have plug in our 1 first. It's going to be 1 to the power of 10 divided by 10. And then we're going to minus it by, we're going to have 0 to the power of 10 divided by 10. Okay. Then therefore, we know that this is going to be equal to 0. And we don't have to include it. This is going to be 1 over 8 multiplied by, it's going to be 1 to the power of 10, which is still equal to 1 divided by 10. And then obviously we can multiply the numerator with the numerator and denominator with the denominator. We'll get 1 divided by 80, which is our final answer for the number 3. Now let's move on to the last one. Holy crap, what is this? Yeah, it's a yeah, I know I'm uncut over here. That's basically my reaction when I saw this for the first time, but then I realized it was so easy. Now let's go through this together. Okay, it's the last one. What we need to consider is the fact that the integral with constants as its upper and lower limits is right here in the middle. So we want to actually take this to the end, where our final answer will actually be a constant. Okay. Great. And from here, well, we can clearly see that we only have x and y. We don't have z. And you're going to have to pay attention to this one quickly. Okay. Okay. So this is how it's going to look like, right? So this is going to be equal to the integral. We're going to put this one first. We're going to have z equals to 0. Let me do it like this. And then we're going to have 4. Now we have constants as limits. That's perfect. And do we have another z? No, we don't have another z. Okay. But we do have dz. But obviously we're not going to take the dz in. Okay, we're going to put it right at the end. Okay. So then this is by the integral. What we are going to actually do is we are going to take y in the middle because it actually doesn't matter which order. So what I'm going to do, I'm going to rather take y, no specific reason, I just want to. And then we have z, root z, sorry, the square root of z over here. Okay, and do we have another y because this is the y integral? Yes, we do have a y, and here's the y, so we can take that to the integral. And then we have the next integral, which is the x one, x equals to 0 until x equals to root y. Okay, and then what else do we have? We have x cubed, so we can put that with the x integral. And now we need to do it in that order. We have with respect to x, then the next one is y, so it's with respect to y, and then with respect to z, which is exactly the same order, so we don't really need to change anything. Okay. Now from here, let's just take the integral of the middle one. So we're going to have this one here with respect to x. So we're going to obviously do it in red here. This is going to be equal to the integral x equals to 0, and we are going to have root y, and then we're going to have x cubed dx. Now we can straight up just integrate here. It's nothing too crazy. So let's just quickly integrate here. Okay. So we're going to have this equal to, and we're going to put our brackets here. X to the power of 3, the integral of that is x to the power of 4 divided by 4. And we're going to have it evaluated from x equals to 0 and x equals to root y. Apologize about that. The dog is being silly. It's probably going to still bark. But let me just get through this now, okay? We're going to basically plug in, right? We have x is equal to, so which means we can plug these things into the stuff respectively. So this is what it's going to look like. It's going to be root y to the power of 4, got a fright, divided by 4 minus, and we're going to plug in the 0 now. It's raised to the power of 4 divided by 4. And we know that this is going to give us 0, so we don't have to include it. Therefore, what we're going to be left with is, well, we can rewrite this as the following. We can say this is going to be y to the power of 1 over 2 raised to the power of 4 divided by 4. And then this is just going to give us, well, it can also be written as y to the power of 4 divided by 2, which is going to be divided by 4. And we know 4 divided by 2 is equal to 2. So therefore, it's y squared divided by 4. Okay. Okay, great. Now, we can just plug this y squared over 4 into what we have here in the red bracket. So let me just cut to that part. So now this is what we are left with, okay? So clearly, well, now that we have this, we can actually just work with our middle one now, our new middle integral, which is with respect to y. So let's just rewrite that now. It's going to be integral root z, and then we're going to have y equals to 0 and root z, respectively, okay? So it's going to be z, by the way, so I'm going to do that. And we're going to have y multiplied by, we can write this as 1 over 4 multiplied by y squared with respect to y. Perfect. And now from here, we can just simplify. We can take this quarter out of the integral. It will be written like this, 1 over 4 integral of y equals to 0 and y equals to root z. And then we'll have y multiplied by y cubed is equal to y multiplied by y squared is equal to y cubed with respect to y. Okay. Perfect. And now we're going to have 1 over 4. We can actually just integrate straight from here, right? So the integral of y cubed is equal to y to the power of 4 over 4. Okay. And then evaluate it from y equals to 0 and y is equal to root z. Okay. Now from here, this is great. Okay, so let's just plug in. Okay, we're going to have 1 over 4 multiplied by, and we're just going to plug in root z into y. So it's going to be root z to the power of 4 divided by 4. Sorry, this is minus. It's going to be 0 to the power of 4 over 4. And then this can be rewritten as, this is just going to be equal to 0, so we can exclude it. Okay. Therefore, this will be 1 over 4 multiplied by, this also can be written as z to the power of a half raised to the power of 4 divided by 4. And this is basically going to be equal to, so we can just multiply this in, and then it's obviously just going to give us, so it's 1 over 4 multiplied by, it's z to the power of 4 over 2, which is equal to z to the power of 2. And then this is divided by 4. And then we can just write this as, we can multiply the numerator with the numerator and the denominator with the denominator. So this is going to be 16. Okay, so it's z squared divided by 16. So there is our integral with respect to y. So hey, we're left with this now. That's great. One more integral. Let's just push through for the last one. We can rewrite it as the integral from z equals to 0 till 4. And then obviously over here we're gonna have we can take the we can actually rewrite this as 1 over 16 multiplied by z to the power of 2 with respect to z. Okay, and then what we're gonna do, we're gonna take the constant out of the integral. This is gonna be 1 over 16, and then integral z equals to 0 until z equals 4, and then this is gonna be of z squared with respect to z. Okay, we can integrate z squared. And then therefore this will give us 1 over 16 multiplied by, in brackets, we'll have z to the power of 3 over 3. And then we'll have z be equal to, from z equals to 0 to z equals to 4. Okay. And then now over here, what we're going to do is we're going to have 1 over 16 outside of the bracket. And then we're just going to evaluate, right? We're going to work with the 4 first. So it's going to be 4 raised to the power of 3 divided by 3 minus, it's going to be 0 to the power of 3. Sorry, it's the power of 3 divided by 3. This will be equal to 0, and we can exclude that. This will be equal to 1 divided by 16 multiplied by 4 raised to the... What's 4 raised to the power of 3? I have no clue. I don't know. 4 squared is equal to 16. 16 to the power of... Sorry, no, 16 times 4 is equal to... Oh, it's 64. Sorry. Sorry. Damn, a lot of pressure, man. There's this dog. I blame the dog. I'm kidding. I'm just blaming everything. Okay, let's just evaluate further. Okay. Well, now what we can do over here, we can actually just cancel these out such that we get 1, and then this will just be 4. And then therefore what we are left with is the final answer is 4 divided by 3. It's really not that bad. It's just the fact that manipulating is probably the hardest part about this entire thing. I know these are very basic examples, but at the same time, I'm pretty sure in the near future I'll be able to do more intense examples. But for now, this is just like an introduction, I guess, for Calculus 3. Okay.